So today we're going to be going over the most one of the most requested videos. I'm the A plus ambassador, or you can call me the universal data boy. UDB. So if you have got videos to request, you can request them to 097895 and I'll be able to make a video about them, just as I'm going to make about this one. So I'm going to show you how to rewrite. I think I can use this. So I'm going to show you how to rewrite a function, how to write a decimal in form of p over q, and this can be a over b, it can be something, but it's usually something that's repeating. This is for irrational functions, by the way. Irrational functions are those with repeating numbers, so it can be maybe 0.6 like that, which is the same as 0.666 repeated. You can have things like 0.567, this one repeated, which is the same as 0.5676567, just like that. So now how we go about this, there are steps that we use. So the first step, so we're going to have step 1. Step 1, we are going to let x equal to whatever number that we're trying to express in form of p over q. So let the number equal x, so that we can continue on with our expression. So if you have got something like the one I gave you earlier, 0.6666 repeated, we're going to let x equal 0.6666 repeated. If you have got if your number is 0.51 repeated, we're going to select your x equal to 0.515151, like that. So then this step is very, very important, because you're going to see later on how we're going to how it's going to come to use. So now for step 2, what you're going to do is you're going to let you're going to multiply the x by a certain factor of 10, so that the decimal will be right before the repeating functions. So if you have got, maybe if you let your x equal to 0.6666 repeated, this one, the decimal is just before the repeating numbers. So now you can just skip step 2. But then for situations where I've got x being equal to 70, let's say 71.5444 repeating, the 4 is the one that's repeating, so I'm going to multiply this by a certain factor so that the decimal is right before the repeating. So now how can we do this? We can multiply this 1 by 10, both sides by 10 by 10. Then we're going to have 10x being equal to 7015.444. Now our repeating factors are just right after the decimal. If you have got maybe your x, if you let your x equal to 0.571, let's say 0, not repeating yet, maybe 0.5716, and then you have your 16 to be repeating. Let's say this one is where there's a repeating thing, this one the decimal, sorry. So then you're going to multiply your x by, since the 16 is the one repeating, you're going to have 1 2, so you're going to multiply your x by 100, in fact the entire function by 100, so you can have 57.161616 repeating like that. And then this is so that you can have your repeating you can have repeating numbers just after the decimal, so that in this other step, that is step 3, you're going to see how we're going to subtract these, and then they're going to be cancelled out, and then we're going to remain with something that doesn't actually have repeating numbers. So then we go to our step 3. So we're going to have in step 2 we're going to multiply again whatever we had to a number such that the decimal is right after the repeating number. So if you have initially we had our x being equal to 0.6666 repeated, so we're going to multiply this one by a certain factor so that the decimal is right after the repeating function. So for example, we can multiply this one by 10, so then you're going to have your x 10x being equal to 6, that would be 6.6666. So then this one will be so that in step 4 we can subtract these two. Step 4 we can subtract these two. We are going to say 10x is equal to 0.6666 repeated, and then you're going to have your x equal to 0.6666 repeated. Then you're going to subtract these two, and then this is the cardinality of step 3, so that when you subtract this one, this will go, this one will go entirely, because this is the same thing after a decimal. So that minus that is just going to be 6. That minus that is going to be, we're going to have 9x. So that's 9x is equal to 6. Then when you divide, then you're going to divide by 9, so that the x will be alone. Then your x will be equal to 6 over 9, which is the same as when you divide both sides by 3, you're going to have 2 over 3. Then you've expressed a number like this in terms of pure vacuum. So then we're going to repeat the step 3 and 4 for more numbers. So when you're actually alone, these questions come in situations where you don't have a calculator, but when you're actually alone and doing practice, you can try this one. That's 2 divided by 3, it's giving us 0.666, just as we said. Then for step 3 is different according to the kind of number. So when you have something like this one, you're going to, so I think I can remove this page, then we can remain with this one. Yeah, so now for things, when you have your x, when you have got, let's say this was your number, we have got 0.5716 repeating. Then in step 2 we said you're going to let your x, you're going to multiply this by a certain number of times such that it's before the decimal. So that's 100x is equal to 57.16 repeating. That's 1616 repeating, like that. So then in that was step 2. So in step 3, just as we did here, we're going to multiply such that the decimal will be after the repeating number, the first repeating number. So we're going to multiply this one. We can multiply this one by a factor of 10, so that this one will be 1 2 just after the repeating number. So then we're going to have this one multiplied by 100 again, by 100. So this one will be 10,000. X is equal to, when this one is multiplied, it will be 5716.66, 161616 repeating. So then we have got something like this. Then step 3 and 4 are cardinal, so that we can subtract this one and this one. So we're going to subtract this equation and this equation. So we're going to have our 100 x is equal to this will be 57.161616, and then we're going to subtract this. So this one minus that one, that's 0, that's 0, borrow 1 from there, that's 10, borrow 1 from there, that's 9, borrow 1 from there, we get 10 minus that one, that would be 99,000. This one will be equal to, after a decimal we're going to have the 0 because everything was subtracted, which is the cardinality for step 3 and 4. Then when we subtract this side, we're going to have this one minus that one, we can't, we borrow 1 from there, we're going to remain with a 0. That one will be 16 minus 7, that's 9. Here I've got a 0, that's 0 minus 5, it can't, so we get 7 from there, we have 6. 10 minus 5, that's 5. There we have got a 6, and there we've got a 5. So this is equal to that. So then you can divide both sides. This is x. You can divide both sides by 990 to isolate the x over 990. So then our x is equal to 5659 over 9. 990. So then let's try this with a calculator. 56 50 divided by 99 00. Yeah, we have it in our calculator. 57 0.57161616. So these are the steps that you're going to carry out. So now let me review. So step 1, you're going to let x equal to whatever that is. Step 2, you're going to let x equal to a number whereby the decimal is right before the first repeating number. Then step 3, the function will be let such that the decimal will be after the first repeating number, so that you can subtract in step 4. And then when you subtract, you're going to make x the subject of the formula. We are going to solve for x.